before I totally switch screens. Awesome. So we are recording, and I'm going to go ahead and switch so I can present and show you guys all the fabulous trig. Fantastic. Okay, so we are on page 259, I believe. Excuse me. If I am wrong about that, someone please come off mic and let me know that it's actually a different page number and I'm just trying to screw you up. But it should be 259. Apparently I need more coffee. Give me a second. So we're on page 259 in your trig book. Actually, I'm not going to drink this yet because there's a moment in just a moment. We're going to be writing some stuff down. So the first thing is our review of right triangles in terms of trig functions. So you have your your angle theta, and in reference to theta, you have your different sides of the triangle. The hypotenuse, of course, is always across from the 90, from the right angle. It's the longest side of the triangle. And then we have our other sides. The side adjacent is always next to theta, and then opposite is always the one that's across. So those should be reviewed, just reminding you those exist. All right, so this is where you're going to have to write some stuff down. This is just reviewing SOHCAHTOA. So sine is the opposite over hypotenuse. So you guys are writing all these lovely ratios in your notebook. So I'll give us a minute to copy all of those down. Fantastic ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then all of our reciprocal buddies. Now I'm going to drink my coffee. All right, and I'm going to go ahead and go on because these you should be able to pull from previous notes or knowledge. So I'm going to go ahead and move us forward, but those are our reference sides for triangles, specifically triangles that are not on a coordinate plane. So the last little bit we've been doing unit circle and we've been on the coordinate plane. We talked about sine being the y value and cosine being the x value. That's very specific to the coordinate plane. So this is a little more general when we're not on the coordinate plane. Okay, so we're going to pick it up with example 1, just practicing those trig functions. There is in our directions, not only to find the values of the 6 trig functions, but also that we might need Pythagorean theorem. You could do Pythagorean theorem here, but hopefully we can recognize this is a 3, 4, 5 triangle, and the 5 is the hypotenuse, so it's done correctly. Then I can go through and do all of my trig functions. So my angle's already marked. To help me out, I might mark this is opposite, adjacent, hypotenuse. If that helps you, go ahead and fill that in. Of course, I'm going to erase this because I'm not happy with my P's. They're not pretty enough. Yeah, okay. Much better. All right, so sine would be opposite over hypotenuse. So in this case, that would be 4 over 5. And you can immediately do the reciprocal like Miss Ballard did, flip it, or you can go through and do the others. It really doesn't matter what order you do them in. Cosine is adjacent over hypotenuse, so 3 over 5. That would make this one 5 over 3. For secant, tangent is opposite over adjacent, so 4 over 3. And then cotangent, flip it, 3 over 4. That should be pretty basic, pretty much review of what we've already done. All right, so forward. So here we're going to sketch a right triangle corresponding to the trig function of the acute angle and use Pythagorean theorem to determine the third side and find the remaining trig functions. All right, so my default is with a positive trig value, which today I think all of ours are going to be positive. But with a positive trig value, I tend to draw my triangles like this. My right triangles in this direction. And the reason for that is actually because of the coordinate plane. This triangle would be in quadrant 1 if I was drawing the coordinate plane. You can see that's where the coordinate plane would be. This would be my reference angle theta. And so I'm nicely in quadrant 1. I know the terminal side always, the altitude is drawn to the x-axis. So this matches what we do so much in unit circles. So that's why I'm drawing it this way. It really doesn't matter. This question is not about coordinate planes, so you could draw your triangle any way you want, but that's why I would draw it that way. And then we have opposite over hypotenuse. So I'm going to label that opposite over hypotenuse. I almost labeled the adjacent. That was very special. Okay, so, and again, I'm not happy with my 2. Now it's better. All right, so I have opposite and hypotenuse. I need my third side, my adjacent. In order to find that, I'm going to set up Pythagorean Theorem. And I'm going to remind you when you do Pythagorean Theorem that your c squared in a squared plus b squared equals c squared. That c must be your hypotenuse. The other 2 don't matter so much, so I'm going to say x squared plus 2 squared equals 3 squared. And so I get x squared plus 4 equals 9. I'm going to subtract that 4 from both sides. And I get x squared equals, looks like 5. Then to get rid of that squared, I'm going to square root. And I have my final result here is that x is going to be the square root, not of x, excuse me, the square root of 5. Here, I'm not going to worry about the negative version because, again, triangle length won't be negative, and we're not on the coordinate plane, so we don't have to worry about a negative. So just positive square root of 5. I'm going to pop that up here like so. And now I have all 3 sides. I can even label them to help me out. Here's my hypotenuse, opposite, and then adjacent. And here we go with our trig functions. Starting with sine theta is opposite over hypotenuse. Oh, they already gave us that one. Huh, I just did one for free. Or they did one for free. I don't know, something. All right, then cosine is going to be adjacent over hypotenuse. Excuse me. And then we have tangent, which is opposite over adjacent, or could be sine over cosine if you like. So opposite over adjacent is going to be 2 over root 5. And here again, we don't want to leave that square root in the denominator, so I would rationalize, and I get 2 root 5 over 5. Then I'm going to go through and flip them. So cosecant theta is going to be 3 over 2. Secant theta is going to be 3 over root 5. Is there anyone brave enough to tell me, to come on, unmute yourself and tell me what, without me showing the steps, what is going to be the answer for secant theta?
3 square root of 5 over 5.
Perfect. So hopefully, yes, who was that?
Ashley.
Ashley, thank you, Ashley, for sharing. Sorry, because I can't see you guys. So thank you. 3 root 5 over 5. So hopefully you guys start to see how that kind of pattern works when we are rationalizing. It kind of saves time. And then the last one, cotangent. So here, when you go to do your reciprocal, you could flip the literal answer for tangent, but that's going to be really messy. So I'm going to go back to that original tangent, and I'm going to flip that one. So I'm going to do root 5 over 2. That would also be the equivalent of going back to your triangle and saying adjacent over opposite. All right, any questions before I go on? Fantastic. Feel free to interrupt me. This, again, most of this should really be review. We've already done this, even in the time we've been doing trig this year. But we are going to add some new stuff in a little bit. So continuing to practice, same basic idea. I'm going to draw that same boring triangle because I have a positive trig function. And again, that's just my default because I like the unit circle so much that everything is about drawing things in standard position in quadrant 1 when I can, blah, blah, blah. Okay, secant. Secant is going to be hypotenuse over adjacent. Remember, secant is the reciprocal for cosine. So cosine's adjacent over hypotenuse. So secant, I don't know if I said that right. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. Awesome. So I'm going to fill this out. My hypotenuse is 10. My adjacent is 9. Don't mind my cell phone. I do have it on. Did silence it because I'm supposed to get a call about a delivery thing today that's kind of important. So sorry. All right. And then again, I'm missing my, on this one, my opposite side. I'm going to do Pythagorean theorem once again. X squared plus 9 squared equals 10 squared. That's x squared plus 81 equals 100. Then I would subtract 81. I get x squared equals, what is that, 19, I think. And then square root both sides. And I get x equals the square root of 19. Again, not super worried about the negative because of our context here. We don't need a negative length of a side of a triangle. All right, so x is square root 19. And then I'm going to run through and do my trig functions again. Here we go. Sine would be opposite over hypotenuse. So root 19 over 10. I'm really unhappy about that theta. See if I can make it prettier. And then cosine. Cosine, we don't even have to use our triangle because really if they gave us secant, they gave us cosine. But again, adjacent over hypotenuse, 9 over 10. Tangent, opposites over adjacent. And then I go to my reciprocals. Cosecant theta would be 10 over root 19. And I'm going to shortcut it this time. When I do the rationalization, it should be 10 root 19 over 19. All right, then I go to secant, which they already gave us. I'm just going to write it again because I just love to write things down. And cotangent, we have 9 over root 19. Again, doing a shortcut for my rationalization, 9 root 19 over 19. Any questions? 2-second coffee break. Fantastic. Okay. And again, just interrupt if you do have a question. All right. So this should be on to the next page. This is on page 260. Just a review of our 30, 60, 90 triangle, 45, 45, 90 triangle, what I call the three bears and Zach and Cody. Just quick reminders to go from baby bear. Remember, everything's about baby bear, to the hypotenuse, we multiply by 2. And to go backwards, we would divide by 2. And to go from baby bear to mama bear, we multiply by the square root of 3. And to go backwards, we would divide by the square root of 3. And on Zach and Cody, to go from either one of the twins, Zach or Cody, to go to the house side, we multiply by root 2. And to go backwards, we would divide by root 2. Just quick reminders that those exist. All right, so this is actually comes from your textbook. I'm not sure if the new one is structured quite this way. This is from the Trig book. Hopefully you guys had that checked out. You don't need the book to do this, but that's why this formatting is like this. The first thing I want to do is actually talk about the directions. So it says construct an appropriate triangle to complete the table. It says 0 is less than or equal to theta, less than or equal to 90. What the heck is this talking about? Why is it telling us that theta is between 0 and 90? Any brave souls?
Because it's an acute angle.
I agree. Is that Tina?
No, it's Fallon.
Fallon, I'm sorry, Fallon. Okay. It is an acute angle. What was that?
I said, yeah, I'm wrong, aren't I?
No, you're not wrong. You're not wrong. That is a very true statement, not wrong. If Fallon, if I can pick on you a little bit.
Yeah, feel free.
Can you tell me, it is an acute angle. Where are all acute angles found on a graph, on like a coordinate plane?
Yes. I don't know.
I agree. Yes. I like it. Okay, that's okay, Fallon. Thank you for being brave and giving us an answer. All acute angles from 0 to 90, if I draw just a little cheat sheet here. Here's my in degrees. That's 90 degrees. Sorry, that 9 looks pitiful. Okay, 180, 270. That was 0 or 360. Where are all of my 0 to 90 degree angles found?
I don't know, anywhere that's not on the, I should say, I can't, sorry, I can't speak right now.
Let me give you a more specific question. For everyone, which quadrant?
The first quadrant?
There we go. Yeah, first quadrant. Yep, quadrant 1. So the point of all this gibberish right here and right here that we kind of pretty much ignore a lot of times is that that's quadrant 1. as we move forward to, I don't know if we'll totally get there this year, but in the future, it can be important to know which quadrant you're in, because that changes the rules about what's positive, what's negative, which trig functions do which things. So that's what the point of this is we're sticking to quadrant 1. That brings up a small complaint with this triangle. What's wrong with this triangle? If it were in quadrant 1.
It's facing the wrong way.
It's facing the wrong way. Now, does it really matter? No, it's just a triangle. It's fine. Thank you guys for being brave and participating. Yeah, so the triangle really, if I was in quadrant 1, it should be going this way. That's where my triangle should go. But for our purposes, it's going to give us the same result because we're not literally on a graph here. It's all right. But technically, because it's saying 0 to 90 or 0 to pi over 2, which is just the radian version, we actually are in quadrant 1. Okay, well, we're going to just use the triangle as it is. It's fine. Everything's positive, which is the main thing because we're in quadrant 1. We are told we're finding the function. These are basically, this is supposed to be like a table. Here's the things that we're supposed to fill out. They give us the function cosine at 60 degrees. We're supposed to fill out radians and what the value is. So 60 degrees in a radian is pi over 3. That is something that at this point or moving forward, you should just know. So you should really practice those pi over 3, pi over 4, and pi over 6. Those 3 radian measures, you should know what they are in degrees. So pi over 3 is 60. And then our function value from the 60-degree angle, if I find the cosine, that would be adjacent. And hypotenuse, I'm going to get a function value of 1/2. So that's it. That's all we have to do on that one. Forward. Again, we still have those same rules. We should be in quadrant 1, so that triangle really should go the other way. Not a huge deal. This one, what I don't like about it is they give a dead giveaway. They tell us we're doing cosecant and we're doing pi over 4. Dead giveaway by the triangle, what that is in degrees. That's 45 degrees. And then we need the function value. Just a quick reminder that cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So this is hypotenuse over opposite. And so from either one of my 45 degrees, it doesn't matter which one, I want hypotenuse and opposite. So hypotenuse over opposite is going to give me root 2 over 1, or you could just say that's root 2. That was our function value. All right, I think there's one more of these lovelies. This one, again, these are the like headings of what we're finding. The function, the degrees, the radians, and then the value. And this one, we're told we're using tangent, which hopefully we remember is opposite. Sorry, my pen just got mad. Okay. Opposite over adjacent. And then we're given the function value. So the function value is root 3. We have to figure out what angle are they talking about. So whenever you're dealing with trig functions, we know it's supposed to be opposite over adjacent. I would make this a fraction because then I have 2 numbers to work with where I have the square root of 3 is my opposite and the 1 is my adjacent. Which angle is going to match that? Let's go with a brave soul again. Unmute.
60.
It is going to be 60. Who was that?
Casey.
Casey. Thank you, Casey. Nice job. So that would be from the 60, we have the opposite and we have the adjacent. So nicely done. That would be 60 degrees. And then once again, in radians, that's pi over 3. Any questions before we shift gears away from the table? Fantastic. Okay, this next part is so exciting. You guys probably won't think it's exciting, but I love it. You have a lot of stuff to write down, and so I'm going to give a little bit of pause here for you to fill in the blanks. Specifically, pay attention. The first section is the reciprocals. That sine goes with cosecant, and cosecant goes with sine. Notice they are shown as reciprocals, one over the other. but I'm going to talk at you a little bit more. Quotient identities. This one, both of these are really important, but this one we will use all the time. That tangent is sine over cosine. So the reciprocal version is true as well. Cotangent is cosine over sine. But if you can learn that tangent is sine over cosine, you're pretty much set. That's like super important. Really awesome. Then in our last set, and if I go too fast too, you can always pick this up from the video later. You can also look in your trig book. These are all listed out, probably in the inside front cover. They usually have all these trig identities listed for you, so you can find them later as well. All right, so Pythagorean identities, this one right here that I'm starring is the most important. If you learn nothing else, you must learn this. Ooh, joke of the day. Oh my goodness. Not really a joke. It's like a pun or a pickup line. But you guys didn't know it last year when we did geometry. You didn't know enough about trig for this to make sense, but it is something I said. And actually, I have a shirt. Shoot. Maybe at the end, I'll go grab the shirt that has a version of the pickup line on it. But it's based on sine squared plus cosine squared equals 1. So here it is. Joke of the day. We can still do another one if Pohas found one. That's fine. Okay, but I wish you were sine squared and I was cosine squared. So together we could be 1. Okay. Anyways, I'm excited about it because you guys finally have enough information to understand that. So that one is the most important one. The other two are going to pop up from time to time. Specifically, when you get further into calculus, you'll have some things with derivatives and integrals that have to do with tangent and secant going together, and you'll need to know that cotangent and cosecant go together. Mostly though, if you can learn sine squared plus cosine squared equals 1, you're good. I'm going to actually do a quick second and tell you where this comes from. So we have Pythagorean identities. That gives a hint that it's from the Pythagorean theorem. If I take that one and actually reorder it for a second and call it cosine squared plus sine squared equals 1. So all I did was just put cosine in front and sine in the back. Then we learned from the unit circle that cosine went with x values. So if I replace cosine with x, excuse me, I get x squared plus y squared equals 1, which is the Pythagorean theorem for the unit circle. That's your formula for the circle. That's your, equation for the circle when the radius equals 1. So it's really the Pythagorean theorem just with trig functions. Any questions before we go on? All right, then we should be flipping the page to page 261. And we are going to complete the identity with all of our awesome knowledge. So we have 1 over cosine. That should go with secant, because secant and cosine are reciprocals. Then we have sine over cosine. That's one of those ones I said is really important. That's going to be tangent. And this last one on your paper, please make sure you add in a theta. It was missing, at least in my copy. It said 1 plus cotangent squared, but it always has to have an angle. So make sure you add in that theta. So 1 plus cotangent squared, I believe that one is cosecant squared theta, one of those trig or Pythagorean identities. All right, then let's move right along. So you have a table in your notes that kind of looks like this. This you should have learned in geometry, but you may have like just glossed over it or not really paid attention or cared about it. It does pop up obviously in trig. So we want to make sure we review the concept. So basically, if you look at this top part, we have matching answers, 1/2 and 1/2. And there's something special about these two angles. They are complementary. They add up to 90. So 30 and 60 add up to 90. So when sine and cosine, notice the co, when they, that's part of the deal with, they are cofunctions. There's the co and cofunctions. So sine and cosine, when their angles add up to 90, their answers are the same. I'm going to say that again. When the angles add up to 90, the answers are the same. And vice versa. When sine and cosine have the same answers, their angles add up to 90. And then we can see that on the second part here. We see the angles add up to 90 and the answers are the same. So that is a property of cofunctions. So anything you can see down here in our list, we have sine and cosine, tangent and cotangent, and then actually secant and cosecant are cofunctions. So this is different than our reciprocal relationship. This has to do with the complementary. So you have the cofunctions are complementary angles. Cofunctions go with complementary angles. And that's why you see the 90 minus theta. If I know theta, for example, is 20 degrees, then 90 minus 20 would mean I'm doing sine of 70. So hopefully you can see 70 and 20 add up to 90. So that's why you have the 90 minus. And we also do this in radians. We did that in radians kind of before. We talked about complementary angles. I think today we're sticking to, we're sticking mostly to degrees today. Okay, which is nice because it's a little more familiar. All right, so this is actually our second to last example. We're only going to go through 9 because these are pretty involved. Unless I get brave and I want to do 10 because I really like example 10, but we'll see. All right, the plan is to make it through example 9. So we have this, it says use the given values to find the indicated trig functions. So notice I have 2 different angles, sine and cosine. So what we're supposed to realize right away is that I can do the complementary angle and the cofunction. So sine of 60, the complementary angle would be 30. The cofunction is cosine. And I know that that is going to also equal √3/2. I'm going to pause there. Are there any questions, concerns about what I just did? Okay, no question. Then I want a super brave soul again to tell me what would I write as a cofunction situation for the cosine of 60 equals 1/2. What should I write for that one?
Would it be cosine 30 over 1/2?
Super close. I want the cofunction, so the cofunction for cosine would actually be, you're good
Fine,
though.
yeah.
No, that's fine. Sine 30 equals 1/2. Yep, that's it. So once I have that, notice I didn't even try to answer the questions yet. I just said, this is what I'm given. I'm going to do something I know. So now I'm going to go through and look at my questions. So one of my questions was part A says tangent. I haven't even talked about tangent yet. I'm going to skip it. I'm going to go to B, sine of 30. We just wrote that down. It's 1/2. Then I'm going to go to C, cosine 30. We already wrote that one down. It's √3/2. And then I have secant 60. Remember, secant is the reciprocal of cosine. So if cosine of 60 is 1/2, my secant would be 2, because those are reciprocals. And notice it has to be matchy-matchy angles when you're doing the reciprocal. Okay? All right. Then the last one, tangent, is the one that's the trickiest. This one, we get to use the thing I said was really important, that quotient identity. Tangent, I could rewrite as sine of 60 over cosine of 60. That is the quotient identity we just saw a second ago. I'm actually going to go back so you can see it. There it is right there. Tangent theta equals sine over cosine. Okay, so really important. So I just wrote tangent as sine over cosine. Then I can take my values because I know sine of 60 and cosine of 60. So I'm going to do sine of 60 is √3/2. Cosine of 60 is 1/2. We can use that trick we learned recently. If you're dividing by the same number in your fraction, it cancels out. And my answer here is going to be √3. It would have been √3/1, but that's the same as square root of 3. Any questions? Anybody's mind blown? A lot of craziness. I love trig. It's so fun. Okay. I'm going to go forward. We're going to try it again. This one, I will not lie, is harder. It's like Crazy, because we start with tangent of alpha. Look, it's alpha from the Greek alphabet. All right, so we have tangent alpha. It's a little different situation. The first thing I'm going to encourage you to do is to look for the cofunction thing on this one, because we have a lot of different things. We're practicing cofunction. So I'm going to ask a brave soul not to tell me the answer here, but what is the cofunction for tangent?
Cotangent.
It is cotangent. Thank you for sharing. Yes, it is cotangent. So when I fill this out, I'm going to write an expression for cotangent. Okay, cotangent. I don't know what the angle is. So I'm going to say, okay, I know it has to add up to 90. So if I start with 90 degrees and subtract the angle I know, that's going to be the complement. So notice how I kind of snuck that in, 90 minus the angle alpha. And that's a horrible alpha, but oh well. Okay, and then we know that the angles are complementary and the answers are the same. Awesome. So I have that. If I look at my lovelinesses here, that doesn't really seem to help some of the ones I'm trying to find. So I'm going to keep working on this a little bit. Actually, maybe not. Yeah, I'm going to keep working on this a little bit. So I have cotangent of this lovely angle is 3/2. But there is a quotient identity for cotangent. I can rewrite cotangent as cosine over sine. So I'm replacing cotangent with cosine over sine. And that, again, I'm going to actually show you where I got that. I didn't just make that up. That comes from right here. Cotangent is cosine over sine. So I'm using those lots of different identities to help me out here. Oops, one more. Okay, so if I look at it that way, then I can maybe do some more work here. I'm just kind of playing with the stuff that I got. I see in my list that I'm supposed to figure out what sine of 90 minus alpha is. If I look at this literally straight across, I have a fraction equals a fraction. That means that cosine of 90 minus alpha has to equal 3. And sine of 90 minus alpha would also have to equal 2. So I have the answer for this one. Fantastic. Then if I look at what else I'm supposed to find, I found the one that looks the hardest, but I'm going to go back and see now if I can find some other ones. I have secant of alpha. So to do secant of alpha, I would maybe need to know cosine because secant and cosine go together. But that means I need, I'm going to need to know cosine of alpha, which currently I don't have. So I'm going to leave that for a second. I'm going to need to know sine of alpha, which currently I don't have, but that's okay. I'm going to leave it for a second. And I'm going to go to cotangent of alpha, which it also looks like I don't have, but I have tangent, and I know that tangent and cotangent are reciprocals. So this would be 2/3. And I'm going to go back to lovely tangent because I'm trying to figure out what sine of alpha is and what cosine of alpha is. So if I go back to tangent alpha, you can see it's a lot of playing with numbers. I'm going to rewrite this as, not cotangent, excuse me. Tangent, we can rewrite as sine over cosine. And then I get 3/2. So if I look at it that way, that means sine of alpha is 3 and cosine of alpha is 2. Fantastic. And then if I fill those in, my sine, that's 3. My cosine, I didn't actually need cosine, I needed secant. So if I flip that or make it a reciprocal, that would give me secant is 1/2. I also want to point out something that I didn't discuss, but I did leave it here. I want you to see something here is that we had cosine of 90 minus alpha equals 3. If I go down here to a matching answer, I have sine of alpha equals 3. Hopefully you can see I have matching answers and my angles would be complementary because 90 minus alpha equals the other alpha. It's kind of a weird thing, but those are complementary angles. Any questions there? And the same would work for the other one as well, FYI, for the sine, business, and the cosine down here. Those match up. And if you're not sure, you can also look back at our formulas up here. Nope, I went too far. This one. So you can see sine of 90 minus the angle equals cosine of the angle. Let me just make sure I'm clear on where I was saying that. Sine of 90 minus the angle equals cosine of the angle. Sine of 90 minus the angle, so that's this bottom one, this one right here, equals cosine of the angle. So it all matches up. All right, so that one was really intense. Do we have any questions? Okay, so I said our goal was to get to through example 9. Since there's only one more on your page, example 10, and I love it. It's actually won't take us but like a couple seconds. Let's do 10 and then we'll call it after that. So example 10, use our trig identities to transform one side of the equation into the other. So this is important in the directions. One side is going to match the other one. So typically when you're doing these, you do not change one side. You choose one side and you're going to keep it the same. Usually the side that you leave alone is the less complicated side. So this is the side I'm going to choose to keep the same. I'm not going to do anything to the one. I'm going to leave it alone. I'm going to somehow make cosine theta times secant theta. That's the side I'm going to change to make it equal 1, to make it obviously equal 1. So to do that, there's a fantastic relationship between cosine and secant. And there's more than one way to do this, but I'm going to go cosine. I know it has a reciprocal identity that says cosine is equal to 1 over secant theta. And if I multiply that by secant theta and put the secant theta over 1, I end up with the secant thetas canceling and I get 1 over 1. Fantastic. Any questions? All right, and we are super fast. We have like 20 minutes left, but that's fine. I don't want to overload you guys. Some of that was very involved, and the rest of it is just gonna build a little bit. The next couple examples are going to be very similar to this one we just did, but a little more involved. I don't want to explode your brains too much. So I'm going to get rid of this and come back to where I can see you guys. All right. And I want to make sure I get a nice picture of everyone that's here so I can send it to Mrs. Ballard to make sure everybody gets their credit for being here today. And remember, if you guys are here every day, Monday through Thursday, then you get some bonus points on Friday. Ooh, and I need to count. Pohas, did we end up with another joke of the day deal? I'm going to take that as a no. That's okay. I mean, we did get my super awesome pickup line. I've been waiting since I had you guys in geometry to be able to tell you that one and have you understand what I'm talking about. So that's pretty exciting for me. Let me do a quick count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. We were an even split. 12 and 12, tied. Awesome. Thank you for, make sure we're being nice in the chat. 12 and 12, thank you guys so much for coming. If you have any other questions, you can stay back for a second. I'm going to kick off the recording. Thank you guys. Have a great day. Everything will get posted at some point. Summer, the Ed puzzle scores are going in as soon as I can get time to grade them. I was catching up grades a little bit. I got your tests in, but those are coming. Awesome. You guys are free to go. Thank you so much.